Okay, so now we should be pretty comfortable finding the vertex using from standard form, straight from standard form, and we're going to use that to build our table. All right. So just as a brief refresher, what you want to remember is if we've got our quadratic, we know it looks like a parabola or a U shape. Remember that vertex is either the highest or the lowest point. It's that turnaround point. So our vertex is right here. So what we're going to do is figure out what that point is, and then we'll get some other points along the way so that you would be able to draw your own graph. All right. So, like I said, let's start with the vertex because that's the critical point that we really want to start with. So, the equation is written in standard form. All right. So, if we just kind of translate that, that means what's really in front of that x squared is a 1, and we're really adding a negative 36. All right. At least that way I can see how it matches up with standard form. But let's go ahead and get the vertex. So if you remember, we always take the opposite of our middle coefficient. So middle coefficient is a positive 16. So we're going to take the opposite of 16 and we're going to divide by 2 times the first coefficient, the leading coefficient. So we clean things up, negative 16 over 2. Go ahead and do that division. That means our turnaround point, our vertex, the x-coordinate is going to be at negative a. All right? So that's one critical point for us. Let's make sure we make note of that. All right? So now, another set of critical points that we just might like to have are the x-intercepts. Now to get those, we need to factor. So if we factor this, we need to find two numbers that multiply to give us negative 36, but will add to give us 16. So that means if we were to write this in factored form, then we would have, that means x squared plus 16x minus 36 would factor into, well, I know I'm going to have x's at the beginning, so two factors that will add to negative 36, multiply to negative 36 and add to 16. Well, I would look at my factor, so I know 1 and 36, there's no way that's going to, and then one of them have to be negative, so negative 1 or either positive 1 and negative 36. Neither one of those is going to add to give me 16. So I know it's not them. I go to my next set of factors. It could be 2 and negative 18, or it could be negative 2 and positive 18. Well, adding those, this will give me negative 16. This will give me positive 16. So that means my factor form is going to be x minus 2 and then x plus 18. All right, so from there, remember, I can get my x-intercepts. So I would also have x-intercepts at positive 2 and negative 18. So I probably want to put those on my table as well, just so I can have a steady flow for the graph. So let's see, let's skip a space, we'll make that 2, skip a space and make that negative 18. And then those are also critical points. They're just nice to have. Do we necessarily need those particular ones to draw our graph? Not necessarily, but they're easy critical points to find. Okay? So now what I would do is I would just choose a few points to fill in some of my gaps. Um, so if I go 8 away from this, that means this will be 0. So if I go 8 up, that'll be 0. If I go 8 down, I can make this negative 16. And then we can just, we want to keep it balanced, and I'll show you why in just a second. It makes it easier to compute, and it's honestly less work for you. Thumbs up on less work. Alright, so let's just say I go another 2 steps away from 2, so up 2 more, that'll put that at 4. If I go down 2 from negative 18, that'll put that at negative 20. Now I've got some inputs, and I just need to evaluate them. Alright, so let me clean things up a little bit. Now I could plug those values into standard form and probably get done with this in a reasonable amount of time. So it's up to you. You can plug it into the standard form up here, or you could plug it into the factor form since you went ahead and found it for the to get our x-intercepts. Alright, but I'm going to use a factor form just because I think I can do the mental math a little quicker. Alright, so if we start with negative 8, that means this will become negative 8 minus 2, which will give me negative 10. And then if this is negative 8 plus 18, this will be positive 10. And so negative 10 times positive 10 is 100. So my vertex is going to be at negative 8, 100. Alright? So from there, let's go ahead and plug in from our x-intercepts. So if I do negative 18 minus 2, well, that's going to be negative 20. But if I do negative 18 plus 18, that's going to be 0. And it should, because that's an x-intercept. So technically the same thing should happen when we go to plug in 2. Alright, so I'm just going to take those off. So we plug in 2 minus 2, there's my 0 this time. And then 2 plus 18, that's going to be 20. But when I multiply that out, I still have 0. Alright? So now it's just a matter of plugging in the rest of the terms, the rest of the inputs, so we can get our outputs and have a full table. So if I go for the smart thing, in my opinion, is if we plug in the numbers that are easier for us to manage. Alright? So if I plug in 0, 0 minus 2 will make that negative 2. 0 plus 18 will make that still 18. Negative 2 times 18 is going to be, I left my negative off, sorry. Negative 2 times 18 is going to be negative 36. Alright? Well, if I do the same thing with 16, and plug negative 16, I'm sorry, and plug that in, negative 16 minus 2 is negative 18. Negative 16 plus 18 is a 2. That's a negative 36. So this is what I want you to notice. All of my inputs are spaced out the same distance on either side of the vertex. Like I told you, this was a distance of 8, and then this was a distance of 8. So that's why those two values match, because they're the same distance from the vertex. Same thing with 2. 2 is actually 10 steps away from negative 8. Negative 18 is also 10 steps away, So that's why their values match. So really, all I would need to do is find maybe what the value for 4 is, and whatever it is, the value for the output value for negative 20 should be the same. So 4 minus 2 is 2. 4 plus 18 is 22. So 2 times 22 is 44. So I'm going to go on a limb and say that that's also going to be 44. But just to make sure, I'm going to go ahead and check it real quick. If I put in negative 20 minus 2 is negative 22. Negative 20 plus 18 would still be a negative 2. And negative 22 times a negative 22 is a positive 44. All right? So remember, if you keep your inputs spaced out the same distance on either side of the vertex, you only have to do half the work. I could have just, so now I could just find maybe these and know that they'll match all of those values. All right? So let's take a look at another. All right. Now I know some of y'all are probably saying, well, why do I even need to waste my time going to find this from standard form when I can just do factor form, which I'm already so familiar with? Well, sometimes you might not be able to factor your quadratic equation, and especially if you're taking a test or quiz and it's time and you need to fill out the table. Well, looking at this, I may not know right off the top of my head how to factor, or if I can factor. So what I need to do is get inputs in my table so that I can go ahead and probably create my graph. So let's do that. Remember, we need to take the opposite of the middle term. So that's going to be negative 12. And we're going to divide it by 2 times the coefficient of the first term, which is 3. So that'll be negative 12 over 6. That'll give us a negative 2 for our vertex. And we always put that value in the middle. Now that's our turnaround point. Now since I don't know where my x-intercepts are, I'm just going to take one step away each time. So I may make this negative 1, make this 0, make that positive 1, and then just keep counting by 1. So that'll be negative 3, negative 4, and negative 5. All right? So now what I'll do is I'll start to plug in to get my y values. So we got 3 times 2 squared plus 12 times 2 plus 2. Well, 3 squared is 4. So 3 times 4 will give me 12. 12 times 2 is 24. And we add another 2. So let's see, that'll be 36 plus 2. Our vertex should be at, well, it won't be there because I left my negative out. Sorry about that. So let's see, that'll still be 12. That'll make this a negative 24. So let's see, negative 12 plus 2, that'll make that a negative 10. All right, so there we go. 2 negative 10. All right. Now, just goes to show how important negative signs are. All right, but let's keep going. Now remember from the last slide, I really only have to find half these values from the table because they're evenly spaced out. This is 1 step away, and that's 1 step away, so they'll have the same value. So I only have to do half the work. I have 6 spots to fill. I only need to do this about 3 more times. All right, so 3 times negative 1 squared plus 12 times negative 1 plus 2. Well, negative 1 squared is 1. 3 times 1, still 3. 12 times a negative 1 is a negative 12, and then we have to add 2. So 3 plus negative 12, that's negative 9, plus 2 more. That'll put us at negative 7. So that means this is negative 7, and this is negative 7. All right. Let's clear some space and keep going. Alright, so now I'm going to plug in 0. So 3 times 0 squared plus 12 times 0 plus 2. Well, 0 squared is still 0. 3 times 0 is 0. 12 times 0 is 0. And we're adding 2. That's going to be 2. So that means this is positive 2. This is positive 2. And then we can finish things up with positive 1. So 3 times 1 squared plus 12 times 1 plus 2. 1 squared is 1 times 3 is 3. 12 times 1 is 12. Plus another 2, that's 15, so that'll be 17. And there we go. We have a complete table, straight from standard.